Hello friends, this is YouTube channel number Collage for mathematics. Here we have to find number of non-empty equivalence relations on the set 1, 2 and 3. Following will be the number of non-empty equivalence relations. The first relation, which is reflexive, symmetric and transitive, hence equivalence. Second will contain all these three elements and 1, 2, 2, 1 to make it equivalence relation. Third will again contain the first three elements as usual and 2, 3 and 3, 2 to make it equivalence relation. Fourth will be with the initial three elements and in addition 1, 3, 3, 1 to make it equivalence relation. And fifth will be the first three elements and in addition 1, 2, 2, 1, 2, 3, 3, 1 and 1, 3, 3, 1 will also be an equivalence relation. There is another method to find number of non-empty equivalence relations without actually writing such relations like we have just done. For that we have to start by writing 1, 1, 2, then you write this 2 here, then add 1 and 2, write 3 here, add this 2 and 3, write 5 here, then you write this 5 here, add this 5 and this 2, 7 here, then add this 3 and this 7, write 10 here, and then add this 5 and this 10 and write 15 here. You can go on like that, and depending upon the number of elements in the set, you can find out the number of equivalence relations that can be formed out of them. So if there is one element in the set, then the number of equivalence relations is 1. If there are two elements in the set, then the number of equivalence relations is 2. If there are three elements in the set, then the number of equivalence relations is 5. If there are 4 elements, then number of equivalence relations is 15, so on and so forth. In this case, the number of elements in the set are 3, therefore the number of equivalence relations is 5. So the correct answer option is 3, 5. Function is twice differentiable and f of x plus y equals fx into fy shows that we have to consider fx equals b raised to lambda x, where b and lambda are unknowns. F dash of 0 is 4a, and function satisfies this relationship where a is positive, and we have to find area of the region where y is f of ax and x lies between 0 and 2. So let us start with assuming fx equals b raised to lambda x, an exponential function. Its derivative f dash x will be b raised to lambda x ln b into lambda b raised to lambda x ln b. Now f dash 0 is given to be 4a, so putting 0 in place of x, lambda b raised to 0 ln b will be 4a, ln b raised to lambda will be 4a, and b raised to lambda equals e raised to 4a. So this fx becomes e raised to 4a to the power x e raised to 4ax. Differentiating fx, f dash x is 4a into e raised to 4ax, and f double dash x 4a into 4a 16a square e raised to 4ax. Now it is given f double dash x minus 3a into f dash x minus fx is 0. Putting the values 16a square e raised to 4ax minus 3a into 4a into e raised to 4ax minus e raised to 4ax equals 0. Cancelling e raised to 4ax 16a square minus 12a square minus 1 equals 0. 4a square equals 1 gives a equals plus minus half, but we have to take a equals half only because a is given to be positive. Now with value of a, fx becomes e raised to 2x. Now the region of which we have to find the area. This y is f of ax, so f of ax will be e raised to 2ax, but a is half, so this will be e raised to x. Now the graph of e raised to x is of this type and x lies between 0 and 2. So we have to find this area. Integral from 0 to 2 e raised to x dx, e raised to x from 0 to 2 e square minus e raised to 0, that is minus 1. So this is the area of the region e square minus 1. Hence the correct answer option will be 1 e square minus 1. At this triangle PQR, the image of the triangle with vertices, this triangle 1, 3, 3, 1 and 2, 4. In the line, this line x plus 2y equals 2. If the centroid of triangle PQR, this G dash is the point alpha, beta, then we have to find the value of 15 into alpha minus beta. First, we will find centroid of the triangle G whose vertices are given. So G will be 1 plus 3 plus 2, 6 upon 3, 2, comma, 3 plus 1 plus 4, 8 upon 3. We use the formula to find the image of G, which is G dash in the line x plus 2y equals 2, this one, and accordingly this will be x minus this 2 upon coefficient of this x 1 equals y minus this 8 upon 3 upon coefficient of y here 2 equals minus 2 times, substituting x equals this 2 plus this 2 times, substituting for y this 8 upon 3 minus this 2, this 1 square plus this 2 square. X minus 2 upon 1 equals y minus 8 upon 3 upon 2 equals this 2 minus 2 is 0, minus 32 upon 15. Solving for x equals minus 32 upon 15 plus 2 minus 2 upon 15, and solving for y minus 32 upon 15 plus 8 upon 3 minus 64 plus 40 upon 15 minus 24 upon 15. Now the centroid of triangle PQR G dash is given to be alpha, beta. Therefore alpha is minus 2 upon 15 and beta minus 24 upon 15. Now we have to find the value of 15 into alpha minus beta, 15 into minus 2 upon 15 plus 24 upon 15, 15 into 22 upon 15, cancelling 15, we get 22. Hence the correct answer option is 4, 22. Z1, Z2, Z3 are the three complex numbers on the circle where mod Z is 1, which means they lie on a circle of radius 1. Argument Z1 is minus pi by 4, that of Z2 is 0, and that of Z3 is pi by 4. Value of mod of this square is given to be alpha plus beta root 2, where alpha and beta are integers. Then we have to find the value of alpha square plus beta square. Three complex numbers Z1, Z2 and Z3 lie on a circle whose modulus is 1. Therefore mod Z1, mod Z2 and mod Z3 will be each 1. Now we have Z equals modulus of Z into e raised to I theta. So therefore Z1 will be e raised to minus I pi by 4. Therefore Z1 bar will be its conjugate e raised to I pi by 4. Z2 will be 1. So Z2 bar its conjugate will also be 1. Z3 is I pi by 4. Its conjugate bar Z3 will be e raised to minus I pi by 4. Now alpha plus beta root 2 is given to be, that will be e raised to minus I pi by 4 plus e raised to minus I pi by 4 plus e raised to I pi by 4 into e raised to I pi by 4. This will be e raised to minus I pi by 4 plus e raised to minus I pi by 4 plus e raised to I pi by 2. Square of this mod of 2 e raised to minus I pi by 4 plus e raised to I pi by 2 mod square. Now e raised to I theta in the polar form is cos theta plus I sin theta. So therefore this will be 2 into cos pi by 4 minus I sin pi by 4 plus cos pi by 2 plus I sin pi by 2. Square of mod of this. This is mod of 2 into 1 by root 2 minus I upon root 2 plus 0 plus I and square of this mod of root 2 into 1 minus I plus I square of this mod equals mod of root 2 plus I into 1 minus root 2 square of this mod. Now this alpha plus beta root 2 will be root 2 square, that is 2, plus 1 minus root 2 whole square root of it and whole square of it, 2 plus 1 plus 2 minus 2 root 2, 5 minus 2 root 2. Comparing two sides, alpha is 5 and beta minus 2. Therefore, alpha square plus beta square will be 5 square 25 plus minus 2 square 4, 29. Hence, the correct answer option is 4, 29. Here the keywords are principal values of inverse trigonometric functions, and we have to find the sum of the maximum and minimum values of this part. If we carefully observe these, it reminds us of a known relation: sec inverse x plus cosec inverse x equals pi by 2. Cosec inverse x equals pi by 2 minus sec inverse x. Let us put sec inverse x equals t, where t, that is range of sec inverse x, belongs to 0 to pi, as can be clearly seen in the graph of sec inverse x here, 0 to pi, and from which we have to exclude this pi by 2. So now we write this given expression as y equals 16 into t square plus from this pi by 2 minus t whole square. Now we have to find range of t in this given interval. For that we have to find y at the boundary values 0 and pi. We also have to check it for a value of t where the derivative of y is 0. That is when dy by dt is 0. So differentiating this y with respect to t, dy by dt equals 16 times plus 2 times pi by 2 minus t into derivative of minus t minus 1 equals 0. So this will be 16 into 2t plus 2t 4t minus pi equals 0. 4t equals pi, t equals pi by 4. So we will also check y at t equals pi by 4. So first y at t equals 0, from here 16 into pi by 2 square, pi square upon 4, 4 pi square. Then value of y at t equals pi by 4 equals 16 times pi by 4 square, pi square upon 16, plus pi by 2 minus pi by 4, pi by 4 square, pi square upon 16. That will be 2 pi square. Now we will check y at t equals pi, 16 into pi square plus pi by 2 minus pi, pi by 2 square, pi square upon 4, 16 into 5 pi square upon 4, 20 pi square. So we observe that the least value 2 pi square occurs at t equals pi by 4, and the maximum value 20 pi square occurs at t equals pi, and sum of these two values is 20 pi square plus 2 pi square, 22 pi square. So the correct answer option is 4, 22 pi square. In this question, the GP is of increasing positive terms, which means common ratio R is positive, A1 A5 is 28 and A2 plus A4 is 29. With this given information, we will find out A and R, and from this finally we will find out value of A6, which will be A R raised to 5. Now A1 A5 is 28, which means A into A R raised to 4 is 28. A square R raised to 4 is 28. We name this 1. Next, A2 plus A4 is 29. AR plus AR cube equals 29. AR into 1 plus R square is 29. Squaring we get A square R square into 1 plus R square whole square is 29 square. We name this 2. Now we take ratio of 1 and 2. A square R raised to 4 upon A square R square into 1 plus R square whole square equals 28 upon 29 square. Cancelling A square and R square and taking square root, R upon 1 plus R square equals root 28 upon 29, R being positive. Comparing the sides, R equals root 28, 1 plus R square equals 29, R square equals 28, R equals root 28, R being positive. So in both these cases we get the same answer, which means R is root 28 is correct. We put this value of R in 1, A square square root of 28 raised to 4 equals 28. A square into 28 square. A equals 1 upon root 28. Now we got both the first term and common ratio a and r. Now we can write a6 a r raised to 5 1 upon root 28 into square root of 28 raised to 5 square root of 28 raised to 4 28 square. So a6 will be 784. Hence the correct answer option is 3 784. Equations of two lines L1 and L2 are given. We have to find out which of the point given in the option lies on the line of shortest distance between lines L1 and L2, segment AB, perpendicular to both L1 and L2. In order to answer the question, we first have to find the equation of line AB. Let each ratio in the equation of line L1 be lambda and each ratio in the equation of line L2 be mu. So, coordinates of point A will be 2 lambda plus 1, 3 lambda plus 2 and 4 lambda plus 3. Similarly, coordinates of point B will be 3 mu plus 2, 4 mu plus 4 and 5 mu plus 5. Now direction ratios of line AB will be 3 mu plus 2 minus 2 lambda plus 1, 3 mu minus 2 lambda plus 1, etc. 4 mu minus 3 lambda plus 2 and 5 mu minus 4 lambda plus 2. Now AB is perpendicular line L1. So we have this 3 mu minus 2 lambda plus 1, etc. plus 3 times 4 mu minus 3 lambda plus 2 plus 4 times 5 mu minus 4 lambda plus 2 equals 0. After simplification we get 38 mu minus 29 lambda plus 16 equals 0. We name this 1. Similarly, AB is perpendicular L2. So arguing in the same manner, this 3 into this 3 mu minus 2 lambda plus 1 plus etc. 4 into 4 mu minus 3 lambda plus 2 plus 5 times 5 mu minus 4 lambda plus 2 equals 0. After simplification we get 50 mu minus 38 lambda plus 21 equals 0. We name this. Let us solve equations 1 and 2 for mu and lambda. Multiply equation 1 by 50 and equation 2 by 38, which gives, changing the signs, minus 6 lambda plus 2 equals 0 gives lambda equals 1 upon 3. Using value of lambda in equation 1, 38 mu equals 29 upon 3 minus 16 minus 19 upon 3. That gives mu equals minus 1 upon 6. Using lambda equals 1 upon 3, here we get coordinates of point A 5 upon 3, 3 and 13 upon 3, and putting mu equals minus 1 upon 6 here, we will get coordinates of point B 3 upon 2, 10 upon 3 and 25 upon 6. Now DRs of AB will be 3 upon 2 minus 5 upon 3, 1 upon 6, etc. minus 1 upon 3, 1 upon 6. Now by using the coordinates of point A and direction ratios of AB, we write equation of line AB x minus 5 upon 3 upon 1 upon 6 equals y minus 3 upon minus 1 upon 3 equals z minus 13 upon 3 upon 1 upon 6. That will be x minus 5 upon 3 upon 1 equals y minus 3 upon minus 2 equals z minus 13 upon 3 upon 1. Now if we just check this fourth point, putting x equals 14 upon 3, y equals minus 3 and z equals 22 upon 3, each of these ratios becomes 9, telling us that point in the option 4 is the correct answer option. In this question, we have to find product of all solutions of this given equation where x is positive. We will start by taking logs on both sides. 5 ln x square plus 3 equals 8 ln x. 5 ln x square minus 8 ln x plus 3 equals 0. we will put ln x equals t. 5t square minus 8t plus 3 equals 0. 5t minus 3 into t minus 1 equals 0. T is 3 upon 5 and t equals 1. So ln x is 3 upon 5 gives x equals e raised to 3 upon 5 and ln x equals 1 gives x equals e. So product of solutions e raised to 3 upon 5 into e raised to 8 upon 5. So the correct answer option here is 1 e raised to 8 upon 5. We are given this summation of tr where r goes from 1 to n and we have to find limit as n tends to infinity of summation of 1 upon tr. So it is important that we find tr first. Since the summation is given in terms of n, we write Sn equals 1 upon 64 product of the terms in n. Now we have a formula to find Tn, nth term, Sn minus 1. This will be 1 upon 64 into these given terms minus Sn minus 1. For this we will put n minus 1 in place of n. For example, this 2n minus 1 will become 2 into n minus 1 minus 1 2n minus 3. This we write here. Similarly, the remaining 3 terms become 2n minus 1 into 2n plus 1 into 2n plus 3. 1 upon 64 into, we find that we can take terms 2n minus 1, 2n plus 1 and 2n plus 3 common. So it will be these 3 common terms into this 2n plus 5 minus this 2n minus 3. That will be 2n plus 5 minus 2n plus 3. 1 upon 64 into cancelling this 2n, 5 plus 3, 8 into these common terms. So Tn will be product of these 3 terms upon 8. Now for finding this limit, we need 1 upon tr, which will be 1 upon tr 8 upon 2r minus 1 into 2r plus 1 into 2r plus 3. Now let us wipe the upper part. Now the limit as n tends to infinity of summation r from 1 to n of, here we have to make some adjustments in 1 upon tr. If we check the difference between the biggest bracket and this smallest bracket, it is 4. So this we write as this 8 upon 4 limit as n tends to infinity of this summation from 1 to n. In numerator we write for this 4 2r plus 3 minus 2r minus 1 upon these original terms. This becomes 2 limit n tends to infinity of this summation. We divide the numerator separately and write 2r plus 3 upon the denominator minus second part of numerator 2r minus 1 upon the denominator. Cancelling 2r plus 3 and this 2r minus 1. Let us wipe this part and write the whole thing again. 1 upon 2r minus 1 into 2r plus 1 minus 1 upon 2r plus 1 into 2r plus 3. Let us wipe this part. To limit n tends to infinity of summation from r equals 1 to n. For r equals 1, this will become 1 upon 1 into 3 minus this will become 1 upon 3 into 5. Similarly, for r equals 2, this will be 1 upon 3 into 5 minus 1 upon 5 into 7. For r equals 3, 1 upon 5 into 7 minus 1 upon 7 into 9, so and so forth. For r equals n, this last term will be 1 upon 2n plus 1 into 2n plus 3. We observe that minus 1 upon 3 into 5 cancels with this 1 upon 3 into 5. Similarly, this term cancels with this term will cancel with this, and the penultimate term here will cancel with this. So what is left here is only these 2 terms, this one and this one. Now as n tends to infinity, this term will tend to 1 upon infinity to 0. So what we are left with is this 2 into this 1 upon 3, 2 upon 3. So the correct answer option here is 3, 2 upon 3. In question number 11, we have to choose 5 letters from all the English alphabets and arranged in alphabetical order. We have to find total number of ways in which the middle letter is M. If the middle letter, that is third letter, is M, then there will be previous 2 letters and 2 letters after M. There are in all 12 alphabets before M, and out of these 12, 2 are to be chosen, and here there are remaining 13 alphabets after M and 2 are to be chosen. So the total number of ways in which these letters can be arranged is 12C2 multiplied by 13C2, that will be 12 into 11 upon 2 multiplied by 13 into 12 upon 2, 66 multiplied by 78, 5148. So the correct answer option here is 4, 5148. Here x equals x of y means x is a function of y and it is the solution of this differential equation. Further it is given x of 1 is 1 and we have to find x of half, that is x when y is half. We have the given differential equation. Since x is a function of y, we will divide by dy. So y square dx upon dy plus x equals 1 upon y dividing by y square dx by dy plus 1 upon y square into x equals 1 upon y cube, which is a linear differential equation in dx by dy. So integrating factor will be e raised to integral y raised to minus 2 dy y raised to minus 1 upon minus 1 e raised to minus 1 upon y, the integrating factor. Now the general solution of this differential equation will be x times integrating factor e raised to minus 1 upon y equals integral e raised to minus 1 upon y into 1 upon y cube dy plus c. Now to solve the integral on the right hand side, we will put minus 1 upon y equals t, that will be minus of minus 1 upon y square dy equals dt, 1 upon y square dy equals dt. So the solution in here becomes x into e raised to t equals integral e raised to t into minus t dt plus c, because here minus 1 upon y is t, so 1 upon y will be minus t equals minus integral t into e raised to t dt plus c. We solve this integral by integration by parts, minus first function into integral of second e raised to t minus integral of derivative of first, which is 1, into integral of second e raised to t dt plus c equals, this integral is e raised to t, so e raised to t minus t e raised to t plus c e raised to t into 1 minus t plus c. Substituting for t, this will be x e raised to minus 1 upon y equals e raised to minus 1 upon y into 1 plus 1 upon y plus c. Now to find this c, we will use this x of 1 equals 1, means when y equals 1, x equals 1. So using in this equation, we get e raised to minus 1 equals e raised to minus 1 into 1 plus c. So c equals minus 1 upon e. So the particular solution after using c here becomes x e raised to minus 1 upon y equals e raised to minus 1 upon y into 1 plus 1 upon y minus 1 upon e. Let us wipe this part. Finally, we have to find this x of 1 half, which means we have to put y equals half here. So x into e raised to minus 2 equals e raised to minus 2 into 1 plus 2 minus 1 upon e, multiplying throughout by e square. This will be x equals 3 minus e. Hence the correct answer option here is 3 minus e. Here parabola y equals x square plus px minus 3 meets the coordinate axis at points p, q and r. So this is the parabola and it meets the coordinate axis at points p, q and r. This circle with center at minus 1 comma minus 1, this center passes through the points p, q, r, p, q, r. Then we have to find the area of this triangle PQR. Let the parabola cuts the x-axis in point q a comma 0 and point r p comma 0. Point P is on the y-axis. We can find its coordinates by putting x equals 0 in the parabola. That gives y equals minus 3. So the coordinates of this point P will be 0 comma minus 3. Now the center of the circle is minus 1 comma minus 1. So its equation will be x plus 1 whole square plus y plus 1 whole square equals r square. For finding radius r, we will put coordinates of point P in this equation. So So we will put x equals 0 and y equals minus 3. That gives 1 plus 4 equals r square. So r square is 5. So equation of this circle now becomes x plus 1 whole square plus y plus 1 whole square equals 5. Now this circle also passes through points Q and R. So we can put y equals 0 so that it will be x plus 1 whole square plus 1 equals 5. X plus 1 equals plus minus 2. So we have two values of x. The first value is a minus 1 plus 2 1 and the other b minus 1 minus 2 minus 3. Now we have coordinates of p, q and r. P is 0 comma minus 3, q 1 comma 0 and r minus 3 comma 0. So area of triangle PQR is half determinant 0 1 minus 3 minus 3 0 0 1 1 1. That will be 3 into 1 plus 3 6. Circle C has radius 2 and lies in the second quadrant. There is another circle with center 2 comma 5 which intersects circle C in two distinct points shown by these green dots. Its radius b r2 equals r. Center of circle C will be obviously minus 2 comma 2. If the set of all possible values of r is in the interval alpha comma beta, then we have to find 3 beta minus 2 alpha. Distance between the centers C1 and C2 of these two circles will be square root of 2 plus 2 4 square 16 plus 5 minus 2 3 square 9 5. Now we have mod r1 minus r2 is less than distance between centers of two circles C1 C2 is less than r1 plus r2. Mod 2 minus r is less than 5 is less than 2 plus r. So we get two relations. Mod 2 minus r is less than 5 and 5 less than 2 plus r, which gives r greater than 3. This second relation gives minus 5 less than 2 minus r less than 5, minus 7 less than minus r less than 3, 7 greater than r greater than 3. This implies r belongs to closed 3 comma 7, which means 3 is alpha and 7 beta. Now 3 beta minus 2 alpha will be 3 into 7 minus 2 into 3, 21 minus 6, 15. Hence the correct answer option is 1, 15. In this question, function fx is given. I1 is integral fx dx from 0 to pi by 4 and I2 integral x fx dx from 0 to pi by 4. We have to evaluate 7I1 plus 12I2. Given function is which can be written as 7 tan raised to 6x into tan square x plus 1, which is sec square x, minus 3 tan square x into sec square x, which is 7 tan raised to 6x minus 3 tan square x into sec square x. Now I1 is integral from 0 to pi by 4 of f of x. We will put tan x is equal to t differentiating sec square x dx equals dt, and limits from 0 to pi by 4 become 0 to 1. So I1 becomes integral from 0 to 1 7t raised to 6 minus 3t square dt equals t raised to 7 minus t cube from 0 to 1 1 minus 1 0. So integral I1 is 0. We will wipe this part and write I2. I2 is integral x times fx dx. This we will do by integration by parts. So this is u and this part is v. So integrating by parts from 0 to pi by 4. This will be first function into integral of second. For integral of second, we will directly use this part here, tan raised to 7x minus tan cube x from 0 to pi by 4 minus integral derivative of first, that is derivative of x 1 into integral of second, integral from 0 to pi by 4 of, we will write this part as tan cube x into tan raised to 4x minus 1, that can be factorized as tan square x plus 1 into tan square x minus 1 dx. Let us wipe this part. Now this part will become 0 minus integral. For this integral we will put tan x equals t, so that sec square x dx becomes dt, and the limits will change from 0 to pi by 4 to 0 to 1. So this will be integral from 0 to 1 t raised to 5u minus t cube dt, because this tan square x plus 1 is sec square x. This will be minus t raised to 6 upon 6 minus t raised to 4 upon 4 from 0 to 1. 1 upon 6 minus 1 upon 4, 1 upon 12. This is I2. Now we have I1 equals 0 and I2 equals 1 upon 12. So 7I1 plus 12I2 will become 0 plus 12 into 1 upon 12, 1. Hence, the correct answer option here is 3, 1. It is given that function f of x is a real differentiable function such that f of 0 is 1 and f of x plus y is this whole thing. For all x and y being real, we have to find summation of log f of n to the base e. N runs from 1 to 100. Let us write f of x plus y. We have to find summation of log of f of n. So therefore we need to find this fx first. For that we will put y equals 0. So f of x will be f of x into f dash 0 plus f dash x into f of 0. Now in order to get f of x, we have to find this f dash of 0. For that we will put both x and y equals 0 in this expression. So this will be f of 0 equals f of 0 into f dash of 0 plus f dash 0 into f of 0. Now here f of 0 is given to be 1. So we will put this value 1 equals 1 into f dash 0 plus f dash 0 into 1. That gives 2 f dash 0 equals 1. F dash of 0 is half. Now we will use value of this f dash of 0 in this equation and get f of x. So f of x will be half f of x plus f dash x into 1. So we get f dash of x equals half fx. We write dy by dx for f dash x equals half, and here we write y for f of x. Here we got a differential equation which we will solve to find this f of x, from which we will get this f of n. So we get y dx equals 2 dy, separating the variables, 1 upon y dy equals half dx. Now integrating ln y equals half x plus c. Now f of 0 equals 1 means x equals 0, y equals 1. Putting these values in here, we will find c. So ln 1 equals half into 0 plus c, that gives c equals 0. So we get ln y equals x upon 2, that is y equals e raised to x upon 2, that is f of x equals e raised to x by 2, or f of n equals e raised to n upon 2. Now summation ln of fx from 1 to 100 will be summation ln of e raised to n upon 2, that is summation n upon 2. That will be half into sum of first 100 natural numbers is n into n plus 1 upon 2, that is 100 into 101 upon 2. 25u into 101, 25u, 25u. So the correct answer option is 2, 25u, 25u. Set A is from 1 to 10 and set B is of m upon n, where m and n belong to set A. N should be less than n and GCD of m and n should be 1. That means m and n should be coprimes. Then we have to find number of elements in set B. We have to start with the least element n equals 1. Set B will be an empty set because there is no element in A less than 1. For n equals 2, set B will consist only one element, half. N equals 3, B will contain 1 upon 3, 2 upon 3, 2 elements. N equals 4, B will be 1 upon 4. We can't take 2 upon 4. That will be 1 half, which has already been considered here. 3 upon 4, 2 elements. N equals 5, B will be 1 upon 5, 2 upon 5, 3 upon 5, 4 upon 5. N equals 6, B will be 1 upon 6, not 2 upon 6, not 3 upon 6, not 4 upon 6, 5 upon 6. N equals 7, B will be 1 upon 7, 2 upon 7, 3 upon 7, 4 upon 7, 5 upon 7. 6 upon 7. N equals 8. P is 1 upon 8, 3 upon 8, 5 upon 8, 7 upon 8. N equals 9. P will be 1 upon 9, 2 upon 9, 4 upon 9, 5 upon 9, 7 upon 9, 8 upon 9. And finally N equals 10 gives B 1 upon 10, 3 upon 10, 7 upon 10, 9 upon 10. Now let us count number of elements in set B. 0 here, plus 1, plus 2, plus 2, plus 4, plus 2, plus 6, plus 4, plus 6, plus 4. That counts NB to 31. Hence, the correct answer option is 1, 31. Here we have to find the area of the region inside the circle, this one, and outside the parabola, this parabola, which means this area. Equation of the circle is, this shows that center of circle is 2 root 3 comma 0, and this point of intersection can be found out by solving equation of circle and equation of parabola simultaneously. So we write x minus 2 root 3 whole square. In place of y square, we will put 2 root 3x equals 12. X square plus 12 minus 4 root 3x plus 2 root 3x equals 12. Cancelling 12. X square minus 2 root 3x equals 0. X into x minus 2 root 3 equals 0. X equals 0. X equals 2 root 3. So x coordinate of this point will be 2 root 3. Now the required area, 2 times area of the quarter circle minus 2 times integral from 0 to 2 root 3 of square root of this 2 root 3x, 2 root 3 raised to half into x raised to half dx pi by 2 into radius is 2 root 3 and square of it minus 2 into 2 root 3 the power half into integral 2 upon 3 x raised to 3 upon 2 from 0 to 2 root 3. 2 root 3 square will be 12. 12 upon 2 6 pi minus 4 upon 3 into 2 root 3 to the power half into 2 root 3 to the power 3 by 2. 6 pi minus 4 upon 3 into 2 root 3 to the power half plus 3 by 2, 2. So required area will be 6 pi minus 4 upon 3 into 12, 6 pi minus 16. So the correct answer option here is 3, 6 pi minus 16. The keywords are without replacement, 4 white and 6 black balls. First selected is black and second selected is black also. Probability is m upon n. GCD of m and n is 1, which means m and n are co-primes, and we have to find m plus n. This is a case of conditional probability. Let A be the event that the first ball is black, B be the event that second ball is also black. So conditional probability is probability of A when B has occurred, which is probability of A intersection B upon probability of B. Probability of A intersection B is 6 balls out of 10 into, since without replacement, 5 balls out of 9 upon, in probability of B, first ball black out of 10, second ball is also black out of 9 plus first ball is white out of 10 into second ball is black out of remaining 9. Cancelling 90 in the denominator. 30 upon 30 plus 24, 30 upon 54, 5 upon 9. 5 and 9 are co-primes, which is given to be m upon n. So required m plus n is 5 plus 9, 14. Hence the correct answer option is 1, 1, 14. We are given foci of the hyperbola 1, 14 and 1, minus 12. The hyperbola passes through 1, 6. Obviously it will be the vertex because x coordinate of focus and this point is same 1. First we will find distance between foci 2BE, which is difference between the y coordinates of foci 14 and 12. 14 minus 12, 26. Midpoint of foci will be, by midpoint formula, 1 plus 1 upon 2, 1, and 14 minus 12, 2 upon 2, 1, which is this, 1 comma 1. Now the distance of vertex V1 from midpoint of foci 1 comma 1 is B. Difference between y coordinates 6 and 1, 5. So we have B equals 5. We have this 2BE equals 26. So 2 into 5 into E will be 26. That gives eccentricity E 13 upon 5. Now latus rectum L1 L2 is 2A square upon B. And we have for this hyperbola A square equals B square into E square minus 1 5 square, that is 25, E square 13 upon 5 square minus 1, 25 into 144 upon 25. A square is 144. So now the latus rectum becomes 2 into 144 upon 5, 288 upon 5. So the correct answer option is 3, 288 upon 5. Fx is a piecewise function minus 3ax square minus 2 when x is less than 1, and it is a square plus bx when x is greater than or equal to 1. It is differentiable for all x real numbers. A is greater than 1 and b is a real number. Area of the region is enclosed by y equals fx as defined above, and the line y equals minus 20, and this area is given to be alpha plus beta root 3, and hence we have to find the value alpha plus beta. Since fx is differentiable, it is continuous also at x equals 1. Minus 3a minus 2 equals a square plus b. We name this 1. Since fx is differentiable, we can differentiate it. F dash x equals minus 6ax, x less than 1, b, x greater than or equal to 1. Again putting x equals 1, we get minus 6a equals b. We name this 2. Using this value of b in 1, minus 3a minus 2 equals a square minus 6a. That gives a square minus 3a plus 2 equals 0. A minus 2 into a minus 1 equals 0 gives a equals 2 and a equals 1. But since a is greater than 1, we have to reject a equals 1. Now with a equals 2, from equation 2 we get b equals minus 12. So fx becomes minus 6x square minus 2 and 4 minus 12x. Now let us draw the graph of this function. Fx equals minus 6x square minus 2 is of the type y equals minus x square. Its graph will be a downward opening parabola excluding this point 1. Since x is greater than or equal to 1, this straight line 4 minus 12x will go down like this, and it is to be enclosed by line y equals minus 20, say this line. Now we have to find point of intersections, this one and this one. So therefore we will equate minus 6x square minus 2 to this minus 20. That gives x square equals 3, x equals plus minus root 3, but we have to take only minus root 3 because x is less than 1. So this point here is minus root 3. Now we will solve y equals 4 minus 12x and y equals minus 20. 4 minus 12x equals minus 20. 12x equals 24. X equals 2. So here it is 2. We have to come down from this 1. This point here is 1. Now this whole area is given as alpha plus beta root 3 that we can find by adding the area below the parabola from minus root 3 to 1. Upper curve minus 6x square minus 2 minus the lower straight line y equals minus 20, that is minus of minus 20 is plus 20. The x plus area under this straight line integral from 1 to 2 of 4 minus 12x minus of minus 20 plus 20 dx, which equals minus 6x cube upon 3 plus 18x from minus root 3 to 1 plus minus 12x square upon 2 plus 24x from 1 to 2. Let us wipe this initial part. So alpha plus beta root 3 equals 16 minus 6 root 3 minus 18 root 3 plus 24 minus 18. 16 plus 12 root 3 plus 6, 22 plus 12 root 3. Comparing left hand side and right hand side, alpha is 22 and beta 12. So required value alpha plus beta will be 22 plus 12, 34. Final answer. Here, this summation is given to be m upon n, where GCD of m and n is 1, and we have to find m minus n. We have this we write as 11 factorial upon 2r plus 1 factorial into 10 minus 2r factorial into 1 upon 2r plus 2. These two things can be combined and written as 2r plus 2 factorial into 10 minus 2r factorial. In the numerator 11 factorial. If we add these two things, it will be 12. So multiplied by 12 divided by 12. 1 upon 12 summation. 12 into 11 factorial will be 12 factorial, and this 12 factorial along with this part will become 12c 2r plus 2. 1 upon 12 into putting r equals 0, 1, 2, 3 and 5 successively. This will be 12c2 plus 12c4 plus 12c12. Here r is 2, 4, 6, 8, 10 and 12. So there is one term missing, that is 12c0, and this we subtract here 12c0. 1 upon 12 sum from 12c0 to 12c12 is 2 raised to 12 upon 2 minus, for this 12c0 we write 1 upon 12 into 2 raised to 11 minus 1. 2 raised to 11 is 2048 minus 1 2047 upon 12, which is given to be m upon n, implies m equals 2047, n equals 12, so m minus n will be 2035. The correct answer. A is a square matrix of order 3 and determinant of A is minus 2, and this determinant expression is given whose value is 2 raised to m plus n into 3 raised to mn, where m should be greater than n, and we have to find the value of 4m plus 2n. Let us write the given expression in the determinant form. Determinant of 3 adjoint of minus 6 into adjoint of 3a. We have determinant of constant k into matrix A equals k raised to n. N is order of the matrix into determinant of A. So this determinant becomes this 3 cube, because A is of order 3, into determinant of the whole thing inside the determinant adjoint of minus 6 into adjoint of 3a. Now for the sake of simplicity, we will assume this part of the determinant to be x and rewrite it as 3 cube determinant adjoint of x. This will be 3 cube. Now for this adjoint of x, we can write determinant of x to the power 3 minus 1, where 3 is the order of the determinant. Here we have used determinant of adjoint A is determinant of A to the power n minus 1, where n is order of the determinant, 3 cube. Now we will resubstitute the value of x, determinant minus 6, adjoint of 3a, 3 minus 1, 2. This will be 3 cube into cube of this minus 6 into determinant adjoint of 3a, this whole square. This again is as per this rule. Determinant of k into matrix A is k to the power n, determinant of A. This will be 3 cube into minus 6 to the power 6, that will be 6 to the power 6, determinant of adjoint of 3a square. 3 cube into 6 raised to 6. Now this determinant of adjoint 3a square will be determinant of 3a to the power n minus 1, that is 3 minus 1, 2 and whole square. Here we have used determinant of adjoint of a equals determinant of a to the power n minus 1, where n is its order. 3 cube into 6 raised to 6 into determinant 3a to the power 4. 3 cube into 6 raised to 6 into determinant of 3a to the power 4 will be 3 cube into determinant of a to the power 4. That will be 3 cube into 6 raised to 6 into 3 to the power 12 into determinant of a to the power 4. 3 cube 6 raised to 6 is 2 raised to 6 into 3 raised to 6 into 3 raised to 12 into determinant of a is given to be minus 2 raised to 4. This will be 2 raised to 4 into 2 raised to 6 2 raised to 10 into 3 raised to 21. Now this is given in the problem to be 2 raised to m plus n into 3 raised to mn. That gives m plus n equals 10 and mn equals 21. By trial and error, we find m equals 7 and n equals 3 because we also have to maintain m greater than n. So for m plus 2n will be 28 plus 6, 34. The final answer. Equation of line L1 and line L2 is given. This alpha is given to be a real number and these two lines intersect at point B. Equations of line L1, this one, and L2, this one, are given where this alpha is a real number. They intersect at point B. Here P is the foot of the perpendicular. This one from the point A, this one, we have to find the value of 26 alpha into PB whole square. Let each ratio in the equation of line L1 be lambda and each ratio in the equation of line L2 be mu, and since L1 and L2 intersect at B, the coordinates of B will be of the type 3 lambda plus 1 minus lambda plus 1 minus 1. They are also of the type 2 mu plus 2, 0, and alpha mu minus 4. Now equating minus lambda plus 1 to this 0, we get lambda equals 1. We can equate this 3 lambda plus 1 to 2 mu plus 2. So that will be 3 into 1 plus 1 equals 2 mu plus 2. 2 mu equals 2. Therefore mu equals 1. Now we can equate this alpha mu minus 4 to this minus 1. So that will be alpha into 1 minus 4 equals minus 1. That gives alpha equals 3. Now from lambda, mu and alpha, coordinates of B will be 3 into 1 plus 1, 4, minus 1 plus 1, 0, minus 1. We write it here. P is given to be foot of the perpendicular from point A on line L2. Now let us assume each ratio in the equation of line L2 be delta. Therefore, coordinates of foot of perpendicular P will be of the type 2 delta plus 2, 0, alpha delta minus 4. We write it here. Now drs of AP will be 2 delta plus 2 minus 1, 2 delta plus 1, 0 minus 1, minus 1, alpha delta minus 4 plus 1, alpha delta minus 3. Now since AP is perpendicular to line L2, product of their drs will be 0. So 2 into 2 delta plus 1 plus 0 into minus 1 plus alpha into alpha delta minus 3 equals 0. Putting value of alpha, 2 into 2 delta plus 1 plus 3 into 3 delta minus 3 equals 0. 4 delta plus 9 delta, 13 delta equals 7, gives delta equals 7 upon 13. So the coordinates of point P will be 14 upon 13 plus 2, 0, 21 upon 13 minus 4. That will be 40 upon 13, 0, minus 31 upon 13. And we have already found out coordinates of point B, 4, 0, minus 1. Now we have to find PB square by distance formula. 40 upon 13 minus 4 whole square plus minus 31 upon 13 plus 1 whole square. 144 upon 169 plus 18 square 324 upon 169 giving 468 upon 169. Now we have to find the value of 26 alpha into PB square, 26 into 3 into 468 upon 169. 13 2s are 13 13s are 13 1s are 13 3s are 13 6s are. So that gives 6 into 36, 216. So the required value of 26 alpha PB square is 216. Here C bar is projection vector of P bar lambda I cap plus 4 k cap, where lambda is positive. On the vector A bar, it is given that mod A bar plus C bar is 7. Then we have to find the area of parallelogram formed by the vectors B bar and C bar. First, C bar is projection vector of B bar on A bar, which means B bar dot A bar upon mod A bar into A cap. That will be B bar dot A bar upon mod A bar into A bar upon mod A bar, which is in B bar dot A bar we get lambda plus 8 upon mod A bar into mod A bar will be square of mod a bar, that is square of 3, 9 into a bar I cap plus 2j cap plus 2k cap. Now a bar plus c bar is I cap plus 2j cap plus 2k cap plus lambda plus 8 I cap plus 2j cap plus 2k cap upon 9. Taking I cap plus 2j cap plus 2k cap common into 1 plus lambda plus 8 upon 9 lambda plus 17 upon 9 into vector a bar. Now mod a bar plus c bar will be lambda plus 17 upon 9 into square root of 1 plus 4 plus 4 lambda plus 17 upon 3. But mod a bar plus c bar is given to be 7. So 7 equals lambda plus 17 upon 3 gives lambda equals 4, which is given to be positive only. So lambda equals 4 here. With lambda equals 4, p bar becomes 4 I cap plus 4 k cap, and c bar 4 plus 8 12 upon 9 4 upon 3 into a bar. Now area of parallelogram is b bar cross c bar. Determinant ijk 404 4 by 3 8 by 3 8 by 3, that equals 32 upon 3 I cap minus 16 upon 3 j cap 32 upon 3 k cap, which equals 16 upon 3 into 2 I cap minus j cap plus 2 k cap. Now mod b bar cross c bar will be 16 upon 3 into mod of 2 I cap minus j cap plus 2 k cap. Therefore this area of parallelogram will be 16 upon 3 into mod of this vector will be 3. Cancelling 3, this area will be 16 square units, which is the final answer. Friends, if you like this video, please like, share and subscribe to this channel. Thank you.